All right. All right. Welcome back. Welcome back, everybody. So yes, today we're gonna do the discussion material, which is about decision tree. Because decision tree, haha, get it? Anyway, so like, there's kind of, so you can think of there's some kind of flow chart, right? And then you kind of go through all the way down. If there's anything interesting you, like this one, like which movie should I watch? You go through all the each flow chart, right? That's like the basic concept of decision tree. But that's also a good example, I would say, that we can think of how decision tree work. This is an Akinator. Not sure if you have heard of it, but let me also go through uh, the game itself to see how it works. And that's gonna be the similar technique with decision tree, I guess. I don't know like the whole coding behind it, but maybe we'll see how it goes. So basically it's gonna guess, the genie will guess our character or a place or a person or something. You guys in the chat can also try to guess before the Akinator too. That will be great. And if you guys get it before you can't, then you guys win something. I don't know, I don't have a prize, but yeah, it's an anime character. We'll see about that. We'll see about that. Yes, character, but let me see if you guys can guess the name first. Uh, so does your character really exist? No. See, is your character a girl? Yes, she's a girl. From Japanese anime? Nah. Originally from a video game? Java? No, that's from a video game. So do you control your character? Nah, I would say no for this character. From horror game? No, she's not from horror game. Music based? Um, Probably. I would say no. Is your character a human? Yes, she's a human. All right. From a shooting game? No, that's not a shooting game. Yeah. An adult? No, she's a teenager, high school student. Yeah, definitely. Did your character die? Oh, spoilers. Probably. Have a stalker? I don't think so. Nope. Is there a character a hiker? No, she's not. An accessory? Why would she be? No. Treasure 13? Nah, she's not. Yeah. Appears in Yandere Simulator? No, she's not. Short hair? Yes, she's short hair. Pink hair? No, she's not pink hair. Band Circus Survive? No, she's not. Work for Mojang? Not a Minecraft character, sorry. Does your character have blue hair? Yes, she does. Can you guys try to guess? Sorry. PUBG? No. Character from Life is Strange? Yes. Chloe Price. Best girl. That's the one that I guess. Yeah, Chloe Price. Yeah. Good job, Akinator. Yeah. Life is Strange girl. But wrong Life is Strange girl. We can talk about our Life is Strange best girl later, I guess. We can debate about it. Anyway, that's a good game. And yes, this is a good example of decision tree. You you give some kind of conditions, then you try to see which one falls into the category, right? And then you produce the final result. One more go. One more. Sorry about that. I I think that's gonna take too much time. But yeah. But yeah, hopefully that's a good representation of decision tree. Sorry if we have to come back to the boring part, which is lecture. Yeah. Haha. Anywho, I'll close that and can't close it. Why? Oh my God, my computer froze. Not quite. All right, got back. Let me switch back. Let's see, get a screen to this. All right, and yes, that's the Akinator and something similar to the concept of decision tree. Right. So yeah, so for the concept of decision tree, yes, you start at the position at one position, right, and then you give some kind of a criteria, and then you goes into it, like whether that criteria falls into that the one choice or the other. So like this one, say this is also a nice example of like you have it classify whether it's a triangle, it's a upside down, normal rectangular, or a diamond, right? Just goes into here. If this is triangle, is it rotated? Then it goes from you're gonna choose this picture, and there's gonna be some terminology. So the very starting point of yours, this one is gonna be each point is gonna be called node. So like this one is node, right? And it's also a node. This one is also a node. Node is basically some kind of object to hold, kind of like checkpoint, I would say in this case. And the very first node is called root node. So root node. And those ones that are at the very bottom, and then you can't go any way beyond further, that's gonna be called leaf. So kind of like a tree. So you have a tree, you have root, right, and then you have a leaf. So this 4 is gonna be leaf, right? And the one that are not the root and leaf, we're gonna call it internal internal node. So it's gonna be internal node. It's gonna be these two, right? And also something to be aware of for the decision tree, we're gonna have it's gonna have something called tree depth. So basically, it tells us, except for the root node, how far deep is the decision tree from the root node to the leaf, to the longest leaf. So this one is gonna be to be deepest leaf. So this one you're gonna have tree depth is equal to 2, right? Because you have the first layer and then first step and second depth. There's some terminology that you should be aware of, but we'll also revisit this terminology later. All right, and yes, if you look at all the example of the Akinator and the decision tree, you're gonna have to come up with some kind of splitting choice, right? Like the Akinator asks it, is it a character? Is it a character from video game? But then if you switch the question, like if they ask from the beginning, like is it the Life is Strange character? So which you kind of have to think, okay, so then which one should come first, so that it kind of benefits you to reduce the choice into one choice instead of like, or into one answer instead of have like a million answer, right? So that's gonna be all kinds of algorithms that people come up to try to split the criteria. So this one is gonna be falls into the concept of criteria splitting, right? And basically, you have to choose where to split. Or basically, in the machine learning concept, it's gonna be how to choose which feature to split as a splitting point, right? And we have information gain, which is one of the algorithm. There's also another one, which is Gini. but I'll walk through the example of information gain, and Gini is going to be free. If you're interested, you can, excuse me, you can look up later for decision, for the Gini algorithm. But I'll work through the example of information gain to see how it works, right? So this is how the work the algorithm for information gain works, right? There are 5 steps. I don't think I need to read them all, but yeah, you can feel free to pause the video, read it later, or you can just simply listen to me because I'll work through everything again. Right? You calculate entropy, blah blah blah. So let's define some definition. So first one we have the definition. Only have one definition, which is entropy. And entropy basically is a measure of disorder of certainty. Shouldn't be. Sorry, let me correct that. It should be uncertainty. And it's going to range from 0 to 1. So basically, if the entropy is at the value of 1, that means that there's going to be all kind of disorder, and you can be sure whether if you pick, if say like you have a box of green ball and red ball, if there's entropy of 1, that means that there's going to be half of them is going to be green and half of them going to be red, right? And when you randomly pick up one, you're going to have uncertainty of 1 because you're not sure whether you will get the green or you get the red. Meanwhile, another box has all of them is going to be green box or green balls inside of the box, and that's one going to be uncertainty of 0, which is or entropy of 0, which is it has absolute certainty that when you pick up the ball, it will always give you the green balls, and that's the concept of entropy. And we'll see that in action. Let me see. Yeah, let me also copy the page, paste it beforehand. All right. So let's say, for example, so the first one, you have to calculate entropy of target class, right? So let me also write that down. I'm gonna work into the math step by step. You guys don't have to memorize it. I just want to show the math and how can you like calculate everything inside that. So first one, you calculate entropy of your target class. So entropy of target class, I'm gonna pick it as S. And if you look at the data set, we have all kind of data, right? But our target class is gonna be this. We want to decide that depends on the weather condition. Should we go outside or should we stay inside the house? But if you ask me, my answer is this one gonna be always be no, because I want to stay inside and play video game. Who doesn't? Haha. Anyway, for the sake of example, let's assume that this is true, and we calculate the entropy of the target class, which is we want to decide whether to go outside or not, and it's gonna be the negative of probability of you want to go outside. So I was just assign this go outside to no. So I just go with acronym of N times the log of probability go outside is equal to no. So P is probability, but if you don't know about the concept of probability, it's okay. I'll go into the example of probability after this formula. And this is going to be first part of you have probability of go outside is no, right? And you also have to get the probability of go outside is equal to yes too. So go outside is equal to yes times log of same thing, probability of go outside is equal to yes. But what's the value of probability of going outside, right? So let's see. So let us find this first. Probability of going outside is equal to no. That's gonna be, so if you have 14 data set or 14 data, and we count how many of no are there. So we're gonna have one no, 2, 3, 4, 5, right? So out of 14, 5 of them gonna be no for going outside. So that's gonna be our probability of going outside is equal to no. And that, while probability of going outside is equal to yes, you're also gonna count how many of them are there as a yes. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So 9 out of 14 is yes. Is yes. So it's gonna be 9 over 14. And after you have all that, simply plug in the number. So, gosh dang it, which color works best? Let me try. Just plug in those numbers into this formula. And you have something like this. So entropy of your target class is equal to negative 5 over 14 log 5 over 14 right, minus 9 over 14 log 9 over 14. And just some side note, people usually find the log of 2 instead of log base 10. So if you don't know about log, it's like, so say you have, let's see which would work. Let's say 10 is equal to, no, I should go with this. I could go with this, I guess. 9 is equal to 3 to the power of x, right? But we don't know what's the power of x should be, so we use the log of, so we find the log of both sides equal to log of 3x. And you do all the calculation, you're gonna get x is equal to 2. That's the log, which is you find the power number that will make the equation true, instead of having x as your normal cofactor or coefficient like this. Basically, it's working with power, but yeah, we're gonna use that for this algorithm. Why? I don't know, because people come up with it. That will be like the answer. And you're gonna get 0.940 for this case, right? And that's just the first part of calculate entropy of target class. The next one, you're gonna calculate the entropy for each feature's value. So we're gonna pick one category, and we do the same thing. We calculate the entropy of each feature's value, and once we have that, we'll get something called information gain, and we use the information gain to decide whether which feature to be your choice. So let's work on more example then. Let's see. Let me also double check it here. So yeah, you're gonna do something called calculate something called information gain for each feature. So in this example, let's work on the win feature first. So information gain of your target data, and you consider only a win feature. So IG is information gain, right? S just your target, and win is our feature that we choose at the moment. We're gonna get the it's gonna be the formula of the information gain. It's gonna be the entropy of your class, which we already find it in here, minus probability of win. So I'll just go with W for the acronym for win. Win is equal to weak times entropy of win is equal to weak. And it's going to be also minus probability of win is equal to strong times entropy of win equal to strong. You don't have to memorize this, because I don't think that will be, the formula will be used, but I want to, yes, as I also mentioned earlier, I want to write down the formula and work on the math example to see the numbers rather than just a formula, right? And now we have all kinds of variables that we haven't found yet. We know the entropy of the class, which is this 0.94. We still need the probability of win is equal to weak, and entropy of win equal to weak, right? And let's find this. So let's find this first. So probability of wind is equal to weak. So you go into the feature and then look inside this feature. How many data of the wind features are weak, right? So you're gonna count in, like, you have wind, so which is you have 1, 2, 3, 4, 5, 6, 7, 8. It's gonna be 8 out of 14 data. And if you do count the same way for strong wind, you're gonna get 6 over 14. Right? So now we take care of these two, but we still have these two. So let's go with the entropy of wind equal to weak first. And that will be, the formula of that will be wind equal to weak. The entropy of wind equal to weak is it's gonna be negative probability of going outside is equal to no times log of probability of go outside is equal to no. And it's gonna be minus the same thing, but change from going outside to yes. So it's gonna be this and change that to yes instead. And now you're gonna count in. Now that you're gonna reduce the subset into the weak entropy first. So then it will be only look inside the weak data, and then you count how many of them are going outside and going inside. Right? So when you look at the wind data, which is the one that I highlighted, only count for the probability of going outside is equal to no. Only count them. So it's going to be this first one, and the second one is here. Right? So there's going to be only 2 of them. So we have, so this is going to be negative of 2 over 8 log of 2 over 8. And the same thing, you reduce to your weak, and then you count how many of no are there, or how many of yes are there in total. So you can also gonna count 1, 2, 3, 4, 5, 6. So 6 out of 8, and that's gonna be 6 over 8 log. I think it should be log 2. Sorry, it's log 2 of 6 over 8, and that's gonna give you 0.811. And you have that for your entropy of wind is equal to weak. And you do the same thing for entropy of wind equal to strong. But we're gonna skip that for the sake of time. And if we do that, we're gonna get, let me also make a copy of that. And we'll plug in the number at the end, and you see the number, right? But let me do some modification first real quick. Delete that. And yeah, we're gonna also find the entropy of wind is equal to strong. So you're gonna reduce the row to only the strong wind. So like this, D6, and you're gonna get something which like negative 3 over 6 log 2 of 3 over 6 minus 3 over 6 log 2 of 3 over 6. And you're gonna just use the same formula of this, but only consider the strong wind, right? And you're gonna get 1.0. Right. Also add some note here. Only count subset that wind is equal to strong. And the same thing as this one. Count subset of wind is equal to weak. All right. So now let's also revisit the entropy concept. So I also said that at the beginning, you have entropy from range from 0 to 1, right? And 1 means that it has a maximum of uncertainty, which is going to be split into half and half, right? And if you look into the wind, you say that the strong wind, you're going to have you have 6 total data, and 3 of them is no, and also another 3 of them is yes, right? So that's going to be half of them, and then when you try to decide whether you, so like say like you go with majority vote, right? But 3 of them and 3 of them is going to be 2 different sides, so you can't really choose from the majority vote, right? So that's also a concept of entropy, and we use entropy to find the information gain as our algorithm. So, and let's see, you get all kind of entropy from here, right? Entropy of wind equal to strong, entropy of wind equal to weak, and all this probability. We just plug in to the formula of information gain. And you will have something which is the information gain of class data. If you have for the wind feature, it's going to be 0.94 minus 8 over 14, 0.811 minus 6 over 14 times 1, and going to give you 0.048, and that's the number that you want. And keep in mind that's the number for only information gain. When you basically when you split the data on the wind feature, you're gonna get the information gain value, which is 0.048. But the goal of algorithm is that we want to get the highest value of information gain when you try to compare with other feature. So we also have to calculate other feature as well. And I already pre-calculated to save the time. So see, yeah, we compute information gain of every feature, and you will have all these 4. When you're splitting at the wind, you have information gain of 0.048, and same thing for outlook. It's gonna get some number, and temperature, and humidity, right? And basically, you want to choose the maximum one, the maximum information gain as your splitting criteria at the first. So which is gonna be this outlook.
Wait, what does the S stand for, by the way? In the
S is just your target class. So S.
okay.
Yeah,
Okay,
that's just a symbol, but I think we can change it to something else. But
yeah.
I just use this because other example on the online they also use this. But yeah.
Okay. Okay. Thank you.
To be target. Yeah. Does that kind of make sense for this algorithm information gain? You find out entropy, and then you calculate all kind of formulas, and then after that you get the number which is information gain, and then you pick the max one as you're splitting. And then once you're repeating that over and over, you're gonna get some decision tree that looks something like this. And this is like you repeating a couple of times. So yeah, you first splitting at the outlook, right? And then you goes into each choice that they have. So you have for outlook, there are sunny, overcast, and rain, right? So then it could be split into 3 different routes. And you go into 3 different routes, and then simply further calculate the using information gain algorithm to split it down further and further until you get the good result, and then you use that as your decision tree, right? So then the next time when someone get input another their own user data, right? So you can just simply walk through down the decision tree to decide whether should they go outside or not, given their weather, right? And side note that this is after repeating a couple of times. And for your visual visualization, you can see like this is how information gain will look like if you have a low information gain versus high information gain. So when you look at a high information gain, you see that the number, the data of one class will have a high cluster in in each internal node, rather than if you compare your low information gain, right? If you split at the low information gain data, you have some kind of like almost half and half data, and then when you try to like conclude from the leaf node, which is your last node from the decision tree, that whether should you consider this one as a class plus or class minus, you can't really um, decide from this information, right? But then if you have high information gain, you can kind of make a conclusion that okay, then most of them are plus class, so we just classify the data as plus, and this is also the same thing as the minus on the other side of the leaf, right? And that's the concept of uh, information gain. And yes, concept of information gain, and you get the information gain, calculate information gain, and then do all the splitting, and this is how it looks like. Sound cool? But yeah, again, you don't have to memorize everything of the formula. I just want to show the way that people work and calculate it. And yeah, I think this also we also have another algorithm which is Genie that professor also mentioned in the lecture, but I didn't really listen. Haha. Anyway, uh, yeah, I won't go into the algorithm, but if you guys have interest, you can also take a look at my slides that I put on CCLE and check out the video to explain when they decide to decide the splitting criteria. Instead of using the information gain algorithm, you use something called Gini, and you do all kind of like calculating probability square instead of like finding entropy, etc. But yeah, this is gonna be an example that you can take a look at it. And yeah, let's address some issues with the decision tree first, right? So you can see the decision tree from the example that we just worked on is going to be categorical, right? So you have like a certain amount of data, a certain a limited, not limited, concrete, solid. Anyway, it's a categorical data rather than a continuous data, which is a number, right? So if you have continuous data, then it's gonna be hard. Like, should you split at like if you have number range from 1 to 10, right? Should you split at like 5 or 6 or 1 or 2? But what about the distribution of data, etc., right? So this is gonna be how you can deal with your continuous data. So if the data is continuous, you have to first sort the data and then average each adjacent row, and then you do the splitting algorithm at each average data. So like for example, in this example, you have 115, 180, 190, right? You sort them out and then you average the number between of them, and then use that particular number as your splitting criteria, and then you calculate all kind of like your Gini, either Gini or information gain, and then you do the same thing with the of another three, and then you pick one as your first splitting point, and then repeating again and again, something like that. So that's gonna be how you deal with your number. Right. And yeah, you another issues with the decision tree. So you're gonna have into there's gonna be issue of overfitting, because if you say like you just keep splitting and splitting, right? It's gonna come into the point of you will overfit the data. So for example, if you have a data that looks something like this, you just keep splitting the data who will kind of categorize the data, right? But then if you don't like really say where to stop, you might run into some issues, something like at this point. So for example, you say, oh, then I'll just keep splitting. So just go with that, split it, and maybe something like this. You're splitting like here, right? And then you have keep splitting again so that you classify two separate data, right? So it would be something like this, and probably also something like this too, to separate the blue and the red, something like that. We do that, right? This is just like a small example of how you can overfit the data and keep splitting the data. The first issue is that yes, it run into overfit, and the second is that you might also get the it might also consume more resources for your computer to keep track of all kinds of decision trees, so that you know which criteria to split. Like, so you have something like this, and then you may also goes down like here forever. Same thing with the left side, right side, like that, which is going to be too big and too much of a resource for your computer. And if you look into the overfit problem, like if you say like your test data is like a for the rate, it's going to be a rate class, right? You go here, then we'll say, yeah, it should look correct in this case. But if you also like specify that the class, the test data will look goes into here, you say that you classify this new red one as a blue, right? But the true label of them is red. Well, we classify it as a red because it falls into this small room, which is you have a blue, the blue, the blue class in here, but so then we classify the new one as a blue class, but instead the true label is a red one. And if you look into the big picture, like if you don't classify something like this, right, you have the new one, and then you look at the whole area, you're gonna say, okay, then we'll classify this as a red one because most of the data in here are red. So when you put in that number, it's red, right? So that's gonna be issue with the overfitting if you don't try to stop it first when you're splitting the criteria. Does it make sense with the concept of overfitting? All right, cool. And yeah, thanks. Nice. You guys are smart. You guys are getting it so quick. Yeah, and as I also mentioned, we have a problem of overfitting, and you can to deal with the overfitting problem, you can simply just indicate the maximum of tree depth, and then you stop it there. And remember that the concept of the tree depth is here, right? You have some every tree has its own depth, and you can specify like if you run into this like depth one, you can just stop the splitting, and then use the use that number or use the information inside that the node as your judgment, I would say. Yeah. So for example, in this case, you specify the max depth equal to 3, right? So then it goes here. So this is step 1. So depth or d equal to 1 and d equal to 2, right? And then this one is step 3. So all this is step 3, right? And you simply said, here, just ignore everything and just group them all together. And you can see like for this one, you can simply just count how many of them are there as a majority, and then use that majority uh, as your this final decision of your target class. So like this one, you have two yes and one no. So I'm just gonna color it as green and then specify them as yes. So it's gonna be this one is yes roundabout. Haha, get it? Anyway, so same thing with the second node, which is the uh, we specify like is it Friday, Saturday when you want to go to restaurant or something. Anyway, but that's like yeah, I love that song. Right, I'll be around about. No, I shouldn't sing. Anyway, so if you have the data that kind of split at half and half, right? You simply just coin toss. It doesn't really matter. And I'll just say for this example, let's split it as a no in this case. So that's gonna be no. And this one's already already classified as yes anyway, so just ignore that. And then this one, there are 2 yes and 1 no for the alternate, and 2 is more than 1, so just go with that. Go with yes. This one. So we go with yes. Or maybe I could go with yeah. Who's sing yeah again? Yeah. No, that's YouTube, not YouTube. Little Chris? No, whatever. Anyway, yeah, that's gonna be how we uh, specify the tree depth, and we simply do some. This whole thing is gonna be called pruning, which is you cut out the tree, and then simply classify that based on the data that you have from the rest, and then use the majority of that. And this is to prevent the overfitting problem. Make sense? Thumbs up, comment, concern? All right, cool. All right, you guys are getting it so quick, and yes. So yeah, you can specify the max step and inside the decision tree. So for sklearn, you can also specify them as well inside of here. So you have the parameter max step, which is gonna be the decision tree classifier, and you simply just try out different max step and using all kind of using cross validation to do different trials with the different max step. This and then try to print out if the which max step will works out the best for your model, fine for your data set. Yeah, and that's the decision tree. And I was also gonna try to go with the also want to explain the random forest, but I could go with a little bit gentle introduction. I don't want to go into more details, but if you're interested, again, I also put up the link for the random forest and how the example works. But basically, random forest in a nutshell is you do the decision tree with repeating for multiple times, like could go with like 100 times. And say if you give in a data, right, you simply randomly pick out the data, and you can also pick out the same data as well. That's also part of randomization. You pick out the data, a subset of data once, you build a tree based on that, and then just leave the tree like that. And then you repeat it hard again. You pick up the subset of data, build the second tree, pick the another data, build a third tree, right? And then once you get the our like 10 different trees, which in this case we can call it random forest. All right, could go 100 forests, right? And then no, it should be 100 trees because forest is only one forest, right? Yeah, one forest with 100 trees. And when you go given a test data, you're gonna use that test data to run through all of the 100 decision tree, and you can pick the maximum value of that class, maximum value of the output. So like for example, 70 of that random tree say yes, and 30 say no. And then you're gonna say, so then from the whole algorithm, it's gonna say 70 is greater than 30 as a yes. So we're gonna pick yes for your new data as your classified data. And that's the algorithm of random forest. And if you're interested, yeah, feel free to also look into this YouTube video too. And yeah, people all come up with all kind of algorithm. And this is for, remember that this is for classify the data. You have the target class, and you try to classify whether you have some kind of data, and you try to classify whether that's like class 0 or class 1 or class 3, something like that too. And yeah, that's a discussion for materials for today. Yeah, we learn about, so we learn about this decision tree, and you classify the data by quote unquote step into the child, but anyway, step into child nodes, or step into the internal nodes until you leave the leaf node, which is the very bottom of your decision tree. And in order to prevent the overfitting problem, you simply just prune the tree. So that, yes, you simply prune the tree, or you specify the maximum number of max depth of your decision tree. Question, comment, concern for the whole concept of decision tree? Otherwise, we can take a 10 minutes break. Going once, going twice, going twice. All right, let's take a break then, and let's come back at 2 o'clock, shall we? Oh, yeah, it's Usher who sing the yeah. Anyway, that's some random thing that I just remember. Anyway. All right, it's already 2 o'clock, so let's continue. So let's see, we're gonna go over the homework 3, and after that we may talk about the homework 2 a little bit. If you guys have any question, I'll turn into office hours, and maybe you guys can also work on as a group as well if you have any work to do. But otherwise, then that should be the end of the discussion. But let me do the homework 3, talk about homework 3 a little bit, and it's gonna be this screen. Yeah. Uh, yes, for homework 3, let me put on this disclaimer first. This version is the hint version that BTA is gonna still work on it a little bit, and we might send it out to you guys later of the day. But anyway, for that, we can discuss a little bit about their homework uh, logistic. So yes, we'll give you, if we provide you the data set about heart disease, and you try to classify whether someone is suffering from your heart disease or not. Yeah, and this will be all kinds of features that you have to look out for. And yes, you have their target class, which is classified as someone that has disease or no disease, right? And yes, this is we also put on some note inside of the code for you to maybe give you some guideline or some of the concept, or maybe function that you should use in for each case. And I think we can kind of skip this one. Oh yeah, actually let's talk a little bit. So when you analyze the data, you'll see that there are some data that you should be aware of. For example, there's gonna be a data that says, I think, yeah. So like if you classify the data, in this case, the data giving us as 1 or 0 instead of like going for sex and say male or female. So you technically don't have to one hot encode it because it's already provided you as a 1 and 0 already. But if you remember the data augmentation and imputation and scaling, you don't have to put this data inside your scaling. Right? So let me reiterate that if a features data is binary, some kind of binary value, which is like 0, 1, 2, or 3, for example, chest pain, you don't have to put those inside scaling. Just leave it as they are. It's already good enough because it's technically a classified data. It's not a continuous data. Right? So keep that in mind. And I think it's already when you do the data augmentation and stuff. I think let me see where do we put that? Yeah. So for the pipeline, the question already provides some guideline for you that you implement the pipeline, but you can opt out to you can opt out to handle the categorical data however you wish, and you don't need to do the data augmentation. So you don't need to create a new feature based on that. You can simply just do, if there's any missing data, do imputation. Do imputation. For augmentation, you can just don't worry about it in this one, and do the scaling, and only scale the data which is not binary data. So yeah, keep that in mind for this homework. And let me also like scroll back a little bit. I don't think there's anything. Yeah, I think most of them you simply run and then try to follow the instruction. But otherwise, we will also provide some of the pseudocode or the workflow that you should follow. Yeah. So basically, it's gonna be some kind of workflow that you should follow to handle this question, right? So like we will also give you some hint. Like first one, you create the key neighbors classifier, you feed the data and you predict the test data, right? And then you basically comment this one to print out the data, to print out the accuracy. So remember that you also, for the metrics to evaluate the classification result, you can do accuracy, you can do precision, you can do recall, and you can do F1. But you simply just go with the metrics dot and then you pass in the data, and you try to take a look inside the code in here, because you also further use them for the below part inside your cell as well. And yeah, and you draw a confusion matrix, which is already the helper function. You simply provide the data, provide the predicted data, and provide the raw data to this function, and it's already printed out for you. It will be printed out. And just you do all the pipeline, you split the data and do the same thing. And we also provide some pseudocode inside of that. You use KNN and then you do print out the matrix, four matrix of them inside of there, and then display the confusion matrix. If you lost this, okay, you can also maybe hopefully look back into the recording as well in case that you lost. Yeah. Or you can also unmute and ask question too. This one, KNN, yeah. So when you create a KNN, K nearest neighbor, K neighbors object, you in this one, we provide the K values for you. So you basically look through every one of them, create a new KNN model, fit the data, and display the accuracy, right? And then goes back again, look into the second one, which is the K is equal to 2, create a model based on that, and then fit data, print of it, and then you look through again for 3, 5, 7, and until 200. And you simply change the parameter of n neighbors to K, because you already use K inside your for loop. And then we'll skip that into from K nearest neighbor to logistic regression. So this one will be a little bit tricky because you don't simply just do the predict, because normally when you have a model, right, and then you provide the test data and you predict, you're going to be model.predict, and then inside that going to be parentheses your data, right? But that's one way that you do it. But another way is that you also use another method called predict probability or predict prob A, and you pass in the data. And we also provide some note on here, right? Predict probability will return a list of lists, and the small list is going to contain the first element, which is the probability of that data belong to class 0, and the second element will be probability of that data belongs to 1. Right? So then instead of like returning as a class which is like 0 or 1, it may return like 0.3 and then 0.7. So that's going to be the data that you will use. And we also provide some instruction, like you use log regression and predict probability test. So you get the test data probability that which class it belongs to. And you only get the column one, which is you want to get the probability of that data belongs to class 1. Because class 0 is already 0, class 1 is equal to 1. So you can the data already coordinate go together, and we will use that later for the later part, which is to plot the ROC curve. Hopefully that kind of makes sense. Or you can also maybe if you need further explanation, I can also explain it and also write that down, and then maybe like you can also take a look at it later if we decide to send out soon, hopefully, unless Professor stop us. But let's see about that. Yeah. So to be aware of in a short explanation, do the model.predict function and also do the model.predict probability function, because you're going to use that for plotting the ROC curve. And yeah, I think other than that, we also provide most of the pseudocode inside of them, and most of them is going to be the logic, the main logic of the like the part number 3 is basically you create a new model with slightly different parameters, and then you simply print out the matrix of them, which is accuracy, recall, precision, and F1, and then you draw the confusion matrix and you make a graph of our C curve. Then you redo it again by creating another model with slightly different parameters, and then try to see like which one performs better. And you just keep repeating again and again, and simply follow the question. Like this one asks you for a simple logistic regression, and then this one run your logistic regression but set penalty to L1, and then solver to lib linear, and then print out the report accuracy, plot the ROC, and then prints out the area under the curve, and and you basically do the same thing with the support vector machine. You create a support vector machine, you report accuracy, you report all the metrics, you plot out ROC curve, and print out the area under the curve, and then blah 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 inside of that. Yeah, and it already provides the instruction like which parameter that you should set. Right, and I think that's like the main gist of the homework 3. Part 4, I think you basically change the model that you feel like that's the best model, and then see the result of them, see the accuracy when you do like 10K fold cross validation. So they basically change these two, or change the logistic regression and change support vector machine to some kind of parameters that you already did above from the above cell. Yeah. Question, comment, concern? Feel free to unmute, or feel free to put it in the chat, or feel free to maybe further work on it first, and then you can also ask me question, because I feel like if I ask it now, maybe if you guys haven't started it, then you don't really have question. I'm pretty sure you'll have question once you start and you're stuck. Yeah, feel free to ask me question if you get stuck like this evening or tomorrow. We still have like 2 days to work on it, 2 afternoon to work on it. Yeah, you guys should start early. Yeah, and got question, just ask me.
For the bonus questions, should we just do like a for loop to go through all the lambda values?
Yeah. For me, I would do that, because professor also didn't give us a solution for the bonus point. But if you ask me, this is how I would do it. Yeah, just create a bunch of lambdas, and then you use your for loop and you create a logistic regression and see which lambda give you the best score. Yeah, I think that should be enough.
Thank you.
All right. But yeah, if you guys don't have any further question, then that's gonna be it for the recording part. If you guys watch the recording, thanks for watching. Hit the like, subscribe, whatever. I'm not a YouTuber anyway. That's just some indication that this already finished the recording. Thanks. Can I get a cake W? No. Anyway, I'll stop recording. And for the rest of you guys, we'll work on your homework too, and maybe group project. And